So guys, now we will see what does the stage 3 does. It takes an input, the assembly code, and produces the machine code, which is an object code or object file. So you can see on the screen on the left hand side is the output of the stage 2 of the compilation process, and it is a pure assembly code. On the right hand side, we can convert this assembly code into the object code using -c flag, right? So you can see I have created test.o object file, but object files are not human readable files. If you try to open this file in an editor, you will only end up with seeing a junk. So thankfully there are tools, objdump kind of a tools, which are used to decode the object files on the Linux platform, right? So let me redirect the output to the temporary file, and then we can see what is there in the temporary file. So you can see on the right hand side, it's the content of the object file test.o. You can see on the left hand side there is a machine code, and on the right hand side is an equivalent assembly code, right? So what is fed to the processor for execution is actually this binary code or machine code, right? So you can see that this binary code or machine code is the hexadecimal representation of your program. And the values on the most left hand side is actually the virtual addresses present in the virtual address space of your program. So you can see, for example, this instruction is located at the virtual address number 4 of the virtual address space of this program. And this instruction is nothing but it is moving some value from the EDI register to the base pointer register, right? So of course, this assembly code itself was a kind of a black box to us, and there is no question that we will going to understand what this binary code is. The bottom line is that you understand the pipeline of the compilation process of a C program, and it is a great interview question. Though you are not expected to decode this assembly code or machine code and tell what actually this code is, but you are expected to know the various stages of the compilation process that the typical C program goes to every time you compile a program and run it. So you can see that for the function compute square and compute circle area, the following is the machine code underneath each of them. And finally, we have the main function, which is also translated into its equivalent machine code. Also, one more thing you can notice is that the information in this object file is properly organized, right? You can see that the information is properly maintained and very much organized. If you notice that information is divided into sections, for example, this is the text section of the program. And if you go down, you can see that this is the section which is called read-only data section, then comment section, and then this is the section called eh_frame, and so on. So this format of the object file on the Linux platform is especially termed as ELF format. The full form of ELF is executable and linkable format. So on Linux platform, all the object files and executables are finally converted into an organized piece of information, and the format is called ELF, executable and linking format. So it's just that you should not be alien to this term ELF. And after stage 3, once we have created all the object files corresponding to all our source file, then the final stage of the compilation process is the linker stage, which we will going to discuss in the next lecture video.